All right, welcome everyone. Um, in this session, I'm planning to uh, do a bit of set of interesting concepts behind Linux processors. So this can be very important for your exploit development and hacking and reverse engineering and system administration, all these purposes. So because end of the day, it's everything is a process, right? So when you really wants to get in touch with processors, of course you should understand there's this interesting commands like ps will give you what are the processors running in your PC or the box, right? Oops. PS3 would give you, oh, I don't have PS3 in my Mac, but the PS command obviously will give you the processors. Okay, so you will find the details of identifying which processor is running by looking at the man page. Yes, BS minus capital A. So this is not really Linux prompt, but yeah, so you can find out a lot of processors running. Right? So Linux processors are quite important to understand. So there's a long list of processors here. Yeah, so we'll go deep into this in a bit, right? Okay, so now when you try understanding a process, it's basically now we have looked into this idea of processes in multiple different ways. We have looked into the process space, address space, the stack, and the queue, and all these things. Right? So basically, a process is a program in execution. So it's a program which is in execution, right? So it has all the necessary elements like the memory and the code and the stack and the heap and all these things, right? So basically, it's execution, right? Instance of execution. So you have the code and which it runs in the memory uh, as as an execution instance. So that's a process. And here, like guys, like I'm not going to try to give definition. This is more of like a practical uh, study about Linux processors, right? And when you talk about processors, now we are going to the operating system concepts. So you can have processors which runs in the foreground, right? So those are called foreground processors, and these are sometimes called as interactive processors as well. Interactive, so they are interacting with the user ideally, right? So when you look at a shell, you can have an interactive process uh, with the terminal, right? And also then they have the background processors. So these are sometimes called as non-interactive. So non-interactive, and also sometimes automatic processors, sometimes daemons. So there are different words used in Linux literature, right? Daemon services, right? So basically you don't need to run this on a terminal in an interactive fashion, right? Okay, so those are the basic concepts of a Linux process. So there are kind of ways of commands that you can put a process to the foreground or put the process to the background. So there are commands which we'll have a look at later, right? And then of course, because we talked about the term daemon, right? So which is up and running service, right? Uh, so we need to have get a basic idea what is it. So it's a background process. So daemon is basically a background process. So background process in action, that is a daemon, right? So normally they don't die. That's the thing. So normally processes die, but these sort of processes normally don't die, right? You can kill it. You can basically close it up, but normally they will run in the system, right? All right. So next, we'll try to understand when you talk about a process, right? So, like your life, it also has states. So you are born, and you get bigger, and you go old, right? And then you die. So that's the process. And similarly, for a process, this is common for even any other operating system, but we'll be looking at exactly the process which is used in Linux. So basically, you get a process created, right? So you'll have a state called create, right? And then so this is something similar to what we did in socket programming. A socket is created, and you had a state chart, something like that. And then a process becomes in the ready state, right? It's in the ready state. All right, ready state, and then the process can run. So running is the most important part. Without running, there's no point, right? So once they are created, then they can go to the ready state where it has all the values, variables for it to work. Then it can be in the running state. And when they're in the running state, they can get interrupted, right? Obviously. So you can, so we will look at some interesting ways you can interrupt the process as well. So you can interrupt the process, and again they can go back to the this particular state model, right, or the particular state. So it's important with the state model because as an administrator or a reverse engineer or a security guy, you should know which state these processes are, right? And the states are created not to, like simply remove a process. So they can be in different states depending on the situation of the operating system. So depending on the need, they can go to different states, right? Right. So this is the interrupt. This is the interrupt, and then after readying, you can run it by having a dispatch, right? You can say dispatch. So you can have a dispatch to run it. So you can have it as a batch process. There are so many different ways of doing that. So when you're dispatching, you have to have a schedule as well. Schedule. So you have to have a scheduler, right? And then what can happen? So when it's running, of course, it can get terminated. So of course, that's where you get killed. Every good thing comes to an end, so this also comes to an end. So basically you can run exit, or you can do bad things like killing. You can kill. So killing is not a kind of a beautiful going out, right? So it's like you are going to forced to go out, right? All right, so that's basically it. Yes, and what are other states? And those are the major states, right? Okay, there's one other state. This can be a bit of an advanced state, but this also you have to learn. Some of the time, because of the priority levels, right? Priorities of the operating system. Any operating system can have priorities, right? Any system can have priorities. Even your life, you have priorities. Right now, the priority should be what? You have to decide to do this or that. So similarly, depending on the priority given for you and the program or whatsoever, you can go into a waiting state. Sometimes you have to wait. So processors also some have to wait. So on what? So based on few different things, probably of input output, or because of an event. Because of events happens. So this or event, right? And you have to wait. So until the IO comes, as you can remember, the accept function. So it is in the wait state. That process is in the wait state until it waits until something happens, right? Is that clear, everyone? There's no point of asking. Clear is a recording, right? Okay, right. So then, if you want to wait, you can obviously come back to the ready state. So of course, you can't go any other state, right? Or maybe in the waiting state, or you can kill if you want to, but rather to make it right. So obviously, because of the IO, if you receive the IO, or so event completion. So event started, event completed. Because of that reason, also you can go to the ready state. So basically, these are the states. First state create, second ready, third run, and from there you have two substates. One is of course terminate, extracting everything. Wait is the other state. So those are the process states. So try to observe this. So this is kind of interesting. All right. Hope it's clear to you guys. So now, then you have to understand a new process is normally created when existing process makes an exact copy of itself in the memory. So those are the ways how we can create a process. And child processors will have the same environment as parents. So normally you do this two different ways. So you can create an exact copy, or you can create a child process. So there are two ways of doing this in Linux when you have to create a process. So I talked about how to create a process, create a P, right? So you can use a system function. So this is a very powerful function, mind you, system function, right? This method is a simple but very significant one. But remember, this is having some security risks. So probably in a different session we talk about it. This is having some security concerns, security risks, right? And then of course you have well-known So famous, forks are so famous, right? Forks, right? So again, threads are something that you can discuss about, which I'm not going to discuss here. And of course, another very powerful function in Linux is exec. Right? So forks and execs are very famous. Yes, so these are less advanced as a function. This is having more functionality with options, but this is having lesser functionality, but still they are very speedy, flexible, and also secure. This is having security risks. So if you use more of this, that's asking for trouble, right? You're asking for trouble. If you're using these ones, yeah, those are more secure, right? So then the comes now when you create the processors, then you get the problem of identifying your processors. So when you want to identify your processors, you have a global index in a Linux system. The first one is called the PID. So that's probably the most important one, process ID. And then when the process is forked from something, that something is called the parent. So this is the parent called the exec or the fork. So if you get the fork, you get exact copy of this, right? So this is the child, and this is having the PID, whereas the parent is getting the PPID, right? PPID stands for parent process ID. So you have parent processors and child processors in a Linux system, right? So okay, so then what we'll do is we'll try to look at some of those processors, probably from okay, so I'll go to my Kali box. So please mind my box is very slow because okay, so now here if you do a PS3, you can find all the processors. I think if you do a PS3 and more, yeah, so I can see all the processors. So I use a flag. I can get the process IDs as well. Yeah, so you can see all the processors. So normally a Linux system is having a lot of processors, right? If you do always get into the use of look into the man page. Yeah, so yes, you get all this PIDs. So I think you can highlight the PIDs, HPID. So that's the tag. Okay, so you have the options here. Yeah, show PGIDs minus G. And minus H will highlight. Okay. And yeah, so you can sort the processors if you want to. So there are so much of things that you can do. Minus P will show the PIDs. Yes. Alright, so I'll do PS3 with the minus P. So you will get all the PIDs. Okay, that's cool. Right, so if I do minus P with the minus H, it will highlight the parent processors as well. All right, so that's done. So then you can do a PS minus AL. It will prompt all the processors in the terminal. You do a PS minus capital A, so you can get all the processors. And if you do a PS minus A and grep, so init. Okay, I don't have init here. Okay, doesn't matter. Right. So what I'm going to do now, I will do PS minus A just to get some understand some processors. So capital A. So you can see some processors. All right, what I should do this with the more. Yeah, so I can see the important processors. So the most important processor is systemd. So normally some other systems you call it as init. Ubuntu based systems is called systemd. So it's for a different discussion. So init, normally you call init. So init is like the major the process which runs in the computer. That's like number one process, right? So before everything this should start. Ubuntu based systems, Debian based systems, you have systemd. We'll have another cool discussion on systemd later on. And then you guys find a lot of other processors like CP, UHP, and Ksoft. What else? So there are a lot of things, right? Yeah, this one, a lot of processors. So you can see the PID is growing, right? So it starts with 1, which is the systemd. All right. So a lot of processors, guys. RPC. Yeah. So you guys have to learn a bit of all these things. Okay, you have SmartD. Cron is there. Cron. VM tools, that's also running. VMware, VMblock. So I'm running this machine on VMware. So some libraries there. Yeah. So that'll be enough. Okay. So later on, so probably remember this process cron 583. So I will be able to use it later. And also I will check on 396 if it needs to be something related to VM. And okay, cool. There's SSH agent 782. All right, so we go ahead now. So we look at some processors. Let me check. I have the PID of command. Yeah, I have the command. So I'm going to check the systemd PID. All right, so systemd PID comes at 730, and okay, let me check. Okay, I'm going to run a command called, so I'm going to zoom this a bit. That's a very nice command called htop. Okay, htop is not there, so I'm going to install it. Sudo apt-get. So if you're doing in a Ubuntu Kali system, always before do any apt-get install, do apt-get update, right? I'm going to install htop. Type in my password. Depending on my connection, it might take a bit of it. Okay, it's done. All right, so I have top. Top is there. That's on top. Cool. So top is running. So top lists down a lot of things later which we'll discuss. Then here I'm going to get the PID of the top. Yeah, so that's a new process. It has PID of 11394. All right, so I can check htop, but I haven't run htop, so still it doesn't have a PID. All right, and so similarly you can get other PIDs. So if you're running any, say as an example, if you're running any browser, sorry, it's a web server, you can get HTTPD. I don't have anything yet, or if you have any DNS related stuff, DNS, so that's also you can check. But at the moment I don't have anything, so leave it aside for the moment, right? Okay, then the shell. This is a shell that we are running, so you can get the values of the shell as well. So if I get try to get the process ID of the shell, cool. I have to do echo. Yeah, so I get the process ID of the shell, which is 1195, and these variables are available, these values. So I think if you go ps, yeah, so you can see the bash PID is that, right? And we have some things PIDs, and yeah, so this is the commands PID. This particular command was a process, and it executed, and it was executed in the process called 11448. All right. Now what is to find? I can do a PS minus capital simple. Yeah, that's fine. So if I do a man PS, can get more information about the PS command. Okay, this one is a pretty nasty command. AUX or AXU. So these commands are pretty useful, powerful. Minus ELF threads. So these are again valuable commands. All right. What is this? What else? Yeah. So those are the commands, right? Okay. Okay. Then you can do get the PPID of the shell bash, putting a PPID, dollar PPID. Yeah, so 1054, right? That's the processors in the shell, right? So then I can start a process, and I can say as an example, I don't know whether I have HTTPD. HTTPD. Okay, it's not that. Okay. What I should do? I should. Where do I have Firefox? Yeah, I have Firefox. So I can run Firefox in this way. I'm a bit worried. I have a limited amount of memory, so I should kill this process. So maybe. Okay, let it open. So I'm going to close it for the moment. Fine. And any case, if you want to put a job to the background, so what you do is you say Firefox, right? So it is very common knowledge among you guys. You can put ampersand. So then it goes to the background, guys. Right? So I think that you understand, right? Okay, if you do a ping, you can do the ping to the background. So you don't get any output, but you can run it in the background without disturbing you. Right. So, and then once you put anything in the background, use the command jobs. Basically, so it's running a ping. Actually, I'm running a ping on the shell, so it's actually stopped now. So it doesn't run any longer. Right. So that's basically how you do a background process. And also, if you want to suspend a command or something, you can use the background command, and you can get it to the front. See, so it's cool. No? So whatever was running in the background, now it's running in the foreground. All right. So I'm going to kill the process. Okay. So that's done. Okay, that's another one. Okay, very good. I don't mind. Okay, so I'm going to get a new tab. Okay, so right. So next section, right? So these things were clear to you. Right. So next, what I'm going to do is, so like I explained, when you run a process, right? So we looked at earlier the process states, right? So similarly, when you run the process, right? So you have this running state, right? Waiting state, and also there's a state called zombie. So the zombie state is basically, so there's a nice state in Linux called zombie state. Right? Zombie state is where a process is dead, it has been halted, but still has an entry. So later on, you look at the process table. In the process table, there's an entry here. So with the process ID 1, 2, 3, 4 something, the entry is there, but the process is not running anymore. So zombie state is something interesting, and then you have the other state like stop state, right? So that's the other state. Stop state is basically stopped, and usually it was given to the operating system kernel, right? So it stopped, and then you have the running and waiting state, so that we have discussed earlier, right? Right. So now we'll have a look at the method of looking at the state. So we have actually looked at it earlier. Of course, one cool way is to use the ps command, and you can use commands like ps -e. Yeah, so there's a list here, and also you can get the head of it or more or something like that. So this will give the first 10 systems or things that is running up and running. Okay. All right. So that's fine. All right. Now we go to the cool tool, right? So the cool tool for me is top, right? So okay. All right, so we were discussing about the top command. So sorry, on the top command again. So the top command is a very useful command. So this is basically a we call that as a system monitoring tool. So you can see a lot of information. One user. So I'm the only user here. Kali. Right, so I'm the Kali user, and root also is running some services. And then you have load average, the load on CPU and things like that. Some services are sleeping, and CPU usage. You can see the CPU usage and some other information, right? And you can see things are moving around because actually changes the way how you're using the CPU and the memory. So as you can see here, CPU is 0.7 and memory is using 6.1 as a percentage. So you can see the one which uses the maximum is at the moment it changes, no time 10, Xorg, some VM tools. And the top is also there. Top is also taking some sort of a memory. And now there's a very important, so you have the user PID is there, process ID is there, CPU usage is there, the time and the command is there. And there's another command called nice. This NI stands for nice. So here the nice command actually it ranges from so let me check. There is nice command. So if you check the nice, run the program with modified scheduling priority. So all processors I told you, you can get priority in Linux, right? Windows also this happens, and you can change this priority by changing this nice value. So you can see nice value here. You can see values like -20 and also 0, and also you can get some values like 20, right? So those are positive numbers or negative numbers. All right. So basically, if it is a negative number like -20, that's the largest value that you can take, means it gets the utmost priority. So please remember, guys. So whatever is a negative gets priority. This in this example, you get ultimate priority. So these are the processes which runs with high priority, right? And 0 mean you're in middle, and if you get positive number, you are on the other side. All right. And some information is there, and even the author's information is there, right? So cool. So there's another command called renice. So you can when it's a running process, you can give renice command. So we'll probably do those things a bit later and see. So nice is an important command. So it's visible in uh, the top. Right? So nice command is visible. So you can get -20. So these things are running with top priority. So now as an example, top is here. So I can give top different priority. So this is running on 20, no? Yeah, 20. So shall I give -20 and see? I think the command is renice, -n 20. Hold on, n. What is the command? N. Nice help. Yeah, priority and the priority number. Yeah, so I would say -n, n, sorry, -n, and -20 for the top. All right, so at the moment top is running in +20. Okay, now I can check whether I can change that. Okay, so I need to get the process ID of top. So there are a few ways to do it. Minus PS space minus capital A, grep. All right, grep top. So okay. So 11786. Okay, so permission denied. I should be running it as the root. So editing sudo. Alright, new priority added. Let's see. That's out of yes. It has a new nice value with high priority. So my guy is running. This bro is running really fast. Alright, with better resources. Alright, so that's what you can do in top. So there are other things that you can do in top, but in this lesson it's more of a quick know-how. So try to understand that you can do so much of things with top. Let's go top. And okay, sorry, I couldn't mention there are so many other things that you can do. You can colorize top by pressing -ZC, so it will colorize. So you can do some crazy stuff with top. So I'm not going to go through all the details. And of course, you can look at specific processors, right? So if you know there's a particular process that you are running, right? So you can do a top with a -u, and then the system B. Okay, invalid user. Check the user first. Yeah, so I can only get processes running with Kali. So that's all. So you can get, right? So you can see the user column is only Kali here. All right. All right. So we were discussing about the top. So other options that you got, we change the nice so there are some commands like you can put a C and get more details about the commands. So basically you get the absolute path when you put C. So where it's running from. So this one actually running from my own shell, so that's why there's no absolute path. So but other things you can see when you press C, you can get the absolute path. So as an example, if I want to know where system D is, it's running all the time places, right? So you can get the details. All right. So that's C, pressing C, and also you can set the D option. Now this refreshes all the time. So this is, you can see, change the time delay from 3 to I can say 10 seconds. Yeah, so then it will change every 10 seconds, right? So otherwise, I cannot find a lot of things. So that will be valuable. And you can kill a process if you want to, finding a PID, and by pressing K option, you can kill a process, right? So I can say K, and then I can give the PID here. Okay, I can give the PID here, and I can basically kill it. Okay. All right, so there are a lot of options here, and I don't know whether because I'm in a terminal. Actually, I'm in my MacBook. I have connected to my other laptop, and I have a terminal, a remote session. So I don't know whether it works. But if you do a Shift P, not sure. So you can get the process CPU utilization, right? So all these details can be. I'm not sure whether it's working. Yeah. So that also is a so important command. Shift P, right? Okay. Right. So then you can do the renizing. So if you do R, right? So PID renize equal to 442. So then you can renize it. All right. So we have done it earlier with a different command, so you can do the rest. So then I will exit, and I will do a very interesting thing. I can save the top command results into a location, right? So whatever the information that I'm going to retrieve from the top command, I can retrieve it to a my results.txt. Okay, so if I do a cat, you can see all the results. So that's not a big deal, but you can get the details like that, right? Okay, so that's basically it. And also there's a nice option in top. So rather than you pressing Q and going out, right, you can run the top for a bit of a time, right? With the -n option, then it will go out rather than I don't have to quit anything. So it will run for like this amount of time and then it will go out. So that's a kind of a neat automation tool. All right, so those are the things about top, right? And of course, there is another command which people take over, top, right? Which is called htop. So let me show htop. If you don't have it, you can install it. If you use a Mac, you can do a brew install, and here you can do a apt-get or a yum installing. So htop, this is more interesting and it's color coded and everything is there. So it's top advanced, right? So we can see here is the CPU, memory, everything is properly listed down. So memory usage, so I have only 2 GB of 3 GB of memory, and I'm using a lot of it. The subspace, all the details are there, right? So and also I see the other details, and from here I can do the killing of something. So again, I need to use the function keys, right? And also try to understand, I can take my mouse over any of these functions, right? Sorry, any of this particular result set, and then I can change things, right? So I can do search, I can do renizing, killing a process. So all these things I can do. So this is a quite a fascinating tool in that sense, right? So I will not take you through a lot of commands because it's almost the same, but remember this is more of a advanced tool. So we can have a complete 1 hour, 2 hour session on htop. The sysadmins or these engineers do use htop. So it's good to always to learn about htop, right? So because it has a lot of information, colors, right? So that is quite useful. Yeah, so basically the function keys are the ones that you have to deal with. Right? So sorry, I cannot use any function keys again because I'm using a Mac, so I have to, I think, use a key combination which I have not looked into, right? So basically this is htop. All right, so now we have looked at it, and then there's another great tool. I don't know whether I install it. Yeah, tool called Glances, right? And this is a crazy tool. So this is much better than top and htop. It's a lot of advanced features, right? A lot of advanced features. So as you can see the CPU, memory, and things like that. And also there's a very nice color combination. So the green color ones says everything is fine, so it's not hurting the system. And sometimes, say if you start something like, see, okay, I'll try to quickly Firefox, start Firefox. It will kill my memory. Oops, what happened? Okay. I'm not in the right place. Okay. That's my Firefox. Right. It should be coming in a second. So once you open something using, okay, it's here, it's in the top 7.8, so it's not bad. But if I open several tabs, I'm not going to do that because I would not be able to run my session here. So I'm not going to do that here right now, right? But you can do the experiment. So open up several tabs, you can see this in red color. No, green, first blue color, right? And when it becomes amber, that means it's really hurting the system, right? So that's why you have to be careful, quite careful. So Glances is a pretty neat tool, right? So which you all have to master, right? So there are plenty of information grab. You can get CPU information, total memory, and memory usage, right? Uh, and also there are other things like average CPU loads are there, as you can see here. Network download, this is very cool, right? So network upload downloads, things are also listed there, and also disk usage, SDA, SDA1, so you can the disk IO related things, and mounted disk device usages, top processors, and also it shows the daytime time on the bottom. What else is there? And also highlights processors, like I said, red that consumes hires, and in this case it's not that bad, right? So so those are the things, right? So you can of course install Glances very quickly, do apt-get, right? Yeah, so if you want to go out from it, just put Q, so that will go out from the terminal. And of course the color coding is green is okay, blue is careful, violet is a warning, alert, red is critical. So I saw here and there was some critical ones also, but not going to hurt us a lot. Okay. So I'm going to close my Firefox. I don't want it to eat my memory. All right. And then, yeah, there are a lot of options here. So you can press A to sort processes, right? And so I'm going to don't try to do a full list here. There's no need to do that, right? Yeah. So and also you can use Glances to go for remote systems, right? To monitor remote systems. Not sure whether I can do that here because it might kill my machine in a way. But if you want to do that, you can monitor the remote system. So you have to say Glances minus S, right? So yeah, so you once you do that, it's running here. So and then you can connect to the server from the other side, and you can connect, or else yeah, so other side what you have to do is you have to say Glances minus C minus capital P, and then you give the IP address. So this is a cool command, right? So right out, it should be Glances, right? Glances. I'm not going to do that right now. Yeah, so those are the cool things about Glances. Okay, so please use that tool. And also there's a another cool tool which lot of guys uses, right? A lot of sysadmins, people like that uses. So we'll get into the tool. Give me a second, guys. Yeah, so we come to that. So now, next, what I wanted to go through is the other set of tools which are important processes. Uh, now, on my top, I will run top in this side, top purge top. It's running. Right. So there's a tool called pgrep. Right. So it's basically to look up for signal process based on the name and other attributes. Right. So these tools can be handy tools that quickly deal with to deal with any type of process. Right. So let me check pgrep. I'll go with the user. My username is Kali, and I want to check the top process which I'm running. All right, so I am running actually two processes somewhere. Yeah, so this one I'm running. I believe this is, that's my top. Yeah, this is the one. So it seems it was 12,000 something. So obviously 12,558. So this is the one. So what I'm going to do now is I'm going to kill that guy. So that's a cool thing to do, right? Killing processes. It's a lot of fun, right? So let me kill it. Kill 12,558. Maybe they'll ask for sudo. We see. Ah, it went out. That's good. Ah, yes. See, it got exited. Right? So it's got exited. So that's a very powerful command. Okay, very powerful command. And then you can do the same command which I did earlier, and of course that process has gone out, right? So similar you can do for answers. If you're running any other process, you can do that. So that's pretty cool, right? So yeah, so those are the other commands that you can deal with, right? So this kill command is quite a powerful command, right? And so it can be used in your system administration processes, your shellcode writing. So there are so many areas there you'll be able to use it. And so understand the fundamentals of the kill is very important. But remember, this is not a kind of a quick grab. So there are a lot of things to understand in this process. So I'll show you the complexity of kill. First I'll do the man page, right? So what you do is send a signal, right? So kill itself is a nice, what you call the Swiss Army knife. So it's a crafter. You can craft signals and send it to the processors. So you can see the default signal for kill is turn. So it uses these things, and you can change it according to your beam. So you can get a list of signals that you can transfer. That's what I want to show. So let me show the list of signals that you can send. So these are signals that you can send. So you have a lot of things here. So you have sig up, sig int, right? And sig quit, sigil, and sig frap. So there's a long list. So if you try to get a basic idea about these commands, right? So let me take to my whiteboard. Okay, I'll take a new whiteboard. I'll give it a second. I'll get a quit. Okay. Alright, so oops, that's a small issue. Okay, so you can see now. Okay, you can see what's there. So what you find here is sig up is a send the process when it's controlling a terminal closed. Sig int is sent to a process by its controlling terminal when the user interrupts the process. So likewise, so there are different signals that you are going to send to the processors. So depending on the situation, you can use this different signal. Right? So now see one example is there's a process which uses a terminal, but the terminal is closed, but the process is hanging around, so you can send a sig up. So likewise, you can send different types of signal depending on the situation. All right. So that's clear. Go back to the, yeah. So now, so you can use kill commands like this. right? So you can check PID of something. So if Firefox is running, that's my Firefox. Okay, I can run Firefox. Okay, then I can check PID. So there are so many commands that we learn. PID of Firefox. Alright, it's not being there. Yeah, so you might have to use a different techniques. Just give me a second. All right. So then you can kill, like even you'll be able to do a p kill here. So Firefox. All right. So yeah. So it exited. Right. So that's also fine. Right. And then we have done the renice. So that's basically about that. Right. So I believe now you got a good idea about Linux processors and how it works. So this is quite important stuff for you to understand, right? And then bit about what happens when you are working with these processors, right? So as I explained systemd or init process, how it works and all that. So it's very important to understand the complete process that Linux OS goes through, right? So initial stage would be the power on stage. In the power on stage, it basically do few things. The initial thing is BIOS, so it checks for basic input and outputs, so that you all know. And basically BIOS loads, scans the devices, right? So it checks all the devices. So that's how it really works, right? And then BIOS search for something called a very important MBR, master boot record, right? So basically it's located in the primary hard drive, and it can load the bootloader. So MBR, once you go to the MBR, it can load the bootloader, which can be grub, mostly grub. Those days we had Lilo also, right? So those are the bootloaders for Linux. And when you look at the MBR, so this is normally space or the size of this is 512 bytes. So you have all these things recorded here. Right, so basically you have all the information related to load content on the MBR, right? So and later on, not later on, but you have to understand, you can write viruses or whatever malware to attack this MBR as well. So you can do malware to attack this, right? Yeah, so it's very important to know about MBR also, right? So and these MBRs will be active records, right? So that's also is important, and if you want to get to these records, you can do it on the Linux box as well. Right, so now I will take to the last part of the today's session. It's quite interesting. I'll go clear first. So what I wanted to do next at the last one, so this will continue, actually this will go to another session which can be interesting, right? But to finish this one, I will take another great and quite fascinating tool which is called htrace, right? Which is called htrace. So htrace is a tool which can do a lot of things, right? Truly speaking, it can do a lot of things because it's a very, I would say, very complicated tool in a way, but every sys engineer or security guy should know about the htrace tool. So I'm not going to do a lot on this. There will be a separate video on the htrace tool, but I will try to cover the very basics of the htrace tool. So htrace tool is basically used to intercept records, the system calls which are called by a process. So if you do a man htrace, normally if you don't get this, you can install this. Right, so this is the manual page. So it's basically trace system calls and signals. So whatever happens in the operating system, especially in terms of processors, where its calls are there, signals are there, everything can be handled by htrace. Everything can be traced by htrace. So it's a very important tool, which is sometimes called diagnostic tool, instructional tool, or a debugging tool. Right? So each line in the trace contains system calls. So as an example, you can have a system call called open dev null with a flag, right? So you have system calls like open. So sometimes you get the very simplest command like a ls command. You will see there are thousands of system calls that will go through in a trace, right? So this is basically what a trace is used for, right? So the normally, like any tool, there's a vanilla command like the hello world of programming. So sysadmin guys, there's a vanilla command, so that would be trace the ls. So what do you think would be the output, right? So it's a crazy output. Yeah, so there's a long output here, right? So of course the easiest way to do this would be, all right, okay, so what I'll do, I will do the S trace, and I will do there's no point of doing a head, so I will do a move, right? Sorry, I'll do the head. I'm not sure I can do a head here. No, I have to put it to direction, no redirection. Anyway, so you can see a lot of content here. Let me now do a different one. So you can probably do S trace for a function. So shall we do, the top is still running, no? So no, top is not running. I'll do htop. So you can get any cool tool that you wanted to S trace. So I'm going to do okay. I'm first going to get the PID. So I'll do a PS AUX. Now you know these commands, and I'm going to grab the htop. All right. So you get 12849. So that's the that's the PID. So I'm going to trace it now. Trace minus P with the PID 12849. Okay. Yes. So it's up running. It's running because the program is running. So you can see write commands. Okay. I will put this. Yeah, so you can see a lot of system calls. You can see writes, calls. So there are so many commands, right? So as you can see, there are a lot of commands, syscall commands. So that's what trace is used for, right? Yeah, so I'm not going to do a lot of things here, but very simply, I just want to show you trace can be used to handle what functions will be called, what system calls will be called in a normal program routine. So we'll do a specific activity with some logic where we do it used for some administration task or a programming task, so then you will get a better idea. So this session is basically just to introduce you the idea of trace, right? All right, so probably one last thing, which is about the proc folder. Actually, I have covered this in a different lesson, but just to give you a quick idea, all this, otherwise this lesson or the tutorial won't be completed. So you have to understand there is this proc folder, which in the Linux file system, it basically handles everything about processors. Okay, everything about processors. Okay. So if I go there, sorry. Yeah, so you can see all the process folders. So this is the process ID 1 and going up to different process IDs. 12 something, our top also is somewhere here. So all the processor IDs are there in the proc folder, right? So once you go into any particular folder, you get a lot of other things like command line, CPU, environment variable, exe. So you can of course go there and have a look at it. I will go to proc 1, right? Okay, and I'll do ls. I can see all these specific things. So I think if you can remember, we looked at the memory. We can see the maps. Yeah, I can see all the assembly. So all these things we have learned, right? All these things we have learned. And so if you, I can do a simple cat on maps. Maps. Okay, so I might have to do a sudo. Yeah, so I can get the memory map, which is really cool. Right, so so this is what's in the proc folder. So we have learned about it, but remember there is also something very useful when it comes to processes. All right, so hope it was clear to you. So in the next session on Linux, so I'll be doing some code practicals with Htrace and probably a system administration task, and understand how to use these processes all together. All right, thank you.